The first point that we are covering is object-oriented ABAP. So in the previous lecture, what we had gone through is the basic concepts of object-oriented ABAP. The first concept that we saw was encapsulation. The second concept that we tried to understand in the previous lecture was abstraction. Okay. There are further two more basic principles of OOPS. Those are inheritance and lastly, the fourth one is polymorphism. Okay. So out of that, we have gone through encapsulation. Encapsulation was defined as clubbing the data and the operations that are to be performed on the data into a single entity called class. So we had covered how the class is declared. Local classes in particular are declared in object-oriented ABAP, and how the class data and instance attributes are created inside the class. After that, we had also gone through the methods that we create inside the class. Both, I guess, we have uh, gone through only the gone through only the instance attributes and instance methods. Okay. Abstraction is revealing only the uh, selected details from the class. Okay. That is called abstraction. Today, what we are going to do is we are going to explore some more concepts of object-oriented ABAP. In particular, we are going to uh, explore the concept of constructors. Okay. So we have two types of constructors in classes. One is the instance constructor, and second one is the static constructor. The instance constructor, it's named as, it has a name, constructor itself. The static constructor is also sometimes called a class constructor. So let's explore constructors in more detail today. Also, we'll try to understand what is public, private, and protected instantiation of a class. Okay, these are today's topics that we are going to discuss. So the first point that we are going to discuss is constructors. Then what we are going to discuss is public, private, and protected instantiation of a class. Then we try to explore the what you can say factory, not factory. What we'll explore is the singleton class concepts. Okay. So the singleton class concept is quite closely coupled with the instance constructor and static constructor. Okay, and public, private, protected instantiation of a class. So let's begin today's class. If possible, we'll try to cover the factory, if possible, in today's lecture, or we'll cover it in tomorrow's lecture if we run out of time. Factory design pattern. Okay. We'll try to cover factory design pattern as well if time permits in today's class. Okay. So as you know that we are trying to explore the OOPS concepts using local classes. Okay. I'll create a new program, zdemo constructor. So this program doesn't exist in the system. We'll create a new program in local classes. Let's let the program be of executable type. Just save it as a local object. So the first step that we do while we create local classes, we create the definition of the class and then we create the implementation of the class. So the syntax for that is class LCL. This is the name of the class LCL constructor demo definition. Okay, then the end class statement comes. Similarly, what we'll do is just simply copy this implementation part. As we know, the class can have three sections. The first section is the public section, okay, followed by the protected section, and finally the private section. Okay, the sections are to be in the written order only, otherwise it causes a syntax error while compiling that we have seen in the previous lecture. Okay, so in the public section, what we'll do is we'll create a constructor method. Okay, for defining the method, the syntax is methods. Okay, constructor. Let it have some importing parameters. Let us say IV value or IV name. Let us say IV name is the importing parameter of type string. In the private section, I will create. Remember, the constructor created here is an instance constructor. Okay, this particular line number 12 syntax, what I have written, methods, constructor, importing. So all these this typing has resulted in creation of an instance constructor. If you are familiar with Java programming or C++ programming, a constructor is a method or function which is responsible for instantiating the class. Okay, what is a constructor? It is a method which is responsible for instantiating a class. Responsible. A method called constructor. Remember, the constructor method will always have the name constructor only. Okay, in Java programming, if you are familiar, or in C++ programming, the constructor function or method has the name which is similar to the class. Okay, that is not the case in ABAP. Okay, the constructor method will have a name constructor irrespective of whatever the name of the class is. So let us say the name of the class is XYZ, the constructor method will have the name constructor only. Okay. Yeah. So we have created an instance constructor here. So I will create some instance data or instance attribute. Okay. So in the private section, I'm creating this attribute. Let us say name is the attribute of type string. Okay. So that's it for now. So what we'll do is we'll try to give the implementation of the constructor method. So simply go to the implementation section of the class, write method. Instead of typing, I'll just use copy paste. It is missing, that's why the syntax error is there. Method and method. So in the constructor, simply what I'm going to do is I will take the importing parameter and set it to the instance attribute. So name is equal to IV. Okay. So what this particular line number 18 is declaring is an instance attribute. We have discussed this in quite detail in the previous class. What is an instance attribute? What is a static attribute? An instance attributes exists only within the object of the class, a static attribute exists for the entire class. Okay, very important. If you have missed out the first lecture, you can always refer it on YouTube on our channel. Later on, we are going to share the links of whatever lectures, demo lectures that have been conducted on object-oriented ABAP in the chat. So you can always refer it. Okay. Our class is ready. We can instantiate our class using constructor. So create a data reference for the class. Hello. The syntax is type reference to, then the class name. That is the reference of our class. So if you want to create an object of the class, what you need to do is either use the create object syntax, or you can use any of the new syntaxes that are available. Using the new operator also you can create an object. Okay, so what we'll do is basically simply we'll use the create object statement. Create object. Why to cause unnecessary confusion? We'll use the old syntax to create the object. Create object this. Or even if you're not comfortable with this syntax, what you can do is you can just go to pattern. You can use ABAP objects pattern. Okay, that also is fine. But I am going to use the create object syntax only here. Create object. Okay, so if I try to do a syntax check on this, okay, what it says is no value was passed to the mandatory parameter IV name. Okay, mandatory parameter IV name, we have only one method, that is the constructor method, and the parameter is IV name. Okay, if you declare additional keyword here optional, then the parameter becomes optional. Okay, but since I had not declared this parameter IV name as optional, the compiler is giving me an error saying that it is a mandatory parameter and you need to pass it. Okay, so let it be a mandatory parameter only. I'll not make it optional. So what this signifies is whenever you try to create an object of the class, what gets invoked is the constructor method. Okay, that too particularly an instance constructor. Remember, we have two constructors with us. One is the instance constructor and one is the static constructor. Currently, what we are discussing is the instance constructor. Okay, so what is clear from this is that whenever you use a create object statement or whenever you use a new statement or new keyword, a new keyword syntax is like this. Okay, and then use the class name. This is more consistent with the Java syntax. Okay, this is the way you create objects in Java. Okay, this particular line number 38 syntax is more consistent with has more consistency with Java syntax. Okay, this is the old syntax to create the object. Yeah, so either you can use the syntax on line 38 or you can use the older syntax, whichever is you are comfortable with. Okay, so I'm comfortable with the old syntax for now. Later on, we can always try to use the new syntax. Yeah, what it is expecting is an importing parameter. The constructor requires an importing parameter. So whenever whatever is importing for the method, while calling that method, what we do is we use the export. While calling, we use it as exporting. Okay. The name of the parameter is IV name is equal to. Okay. Since I have nothing here to pass, so what I'll do is I'll just pass my name as a constant string. Okay. So now let us check what is the situation. Yeah, looks like it worked. So the mandatory parameter has been passed. Now since this name is a private instance attribute, there is no way I can access this outside the class. Okay, let's set a breakpoint there and try to analyze what we have done so far. Okay. Just activate the code. Just a breakpoint on the create object statement and execute. Okay, do an F5 on the create object statement. So just for understanding, this is the reference variable which is initial, no memory has been allocated for it. So once we do a F5, the control goes into the constructor method. Okay. So the name attribute is currently blank because the statement on line number 28 has not yet been executed. Just execute it. The attribute gets set. Memory is allocated for the object. Yellow const and the attribute is also filled. So do an F8. So there is nothing more to execute. We have already seen this. So in order to access this outside the class, if I want to print out the private attribute, so what method we have to adopt is to create another instance method to access this. Okay, uh, private attribute. This is because the the attribute that we're trying to access in the private section. Do a pretty printer. We'll create another method. Get name. Okay. Returning value. So a particular method of a class can have importing parameters, exporting parameters, okay, changing parameters. It can have returning parameters. It can have exception parameters. Okay. The parameters that are possible for any of the class methods are either importing, exporting, changing, returning, and exceptions. These many parameters are possible, okay, in the interface of a class method. Tables parameter is not supported in object-oriented programming. So rest of them, I guess importing, exporting, changing, and exceptions are there in the function module as well. Okay, the only addition is the returning parameter. Okay, there is a restriction in object-oriented ABAP that the returning parameter must always be returned by value and not by reference. Okay, so it's a very important thing that you guys need to remember, that the returning parameter of a class method should always be by value and not by reference. Okay. Get name returning value. What we're trying to return is name. So RV name, that is the naming convention that we'll use. R stands for returning, V stands for value. Okay, RV underscore name type string. Just implement this method. Whenever you declare a method, you need to give its implementation. Get name. That is the end of this statement, and method. And simply what we are going to do is rv underscore name is equal to, either you can write name or you can write me arrow name. Okay, what is this me? Me is the self-reference. Okay, me is like a self-reference to the object who has invoked the method. Okay, what is me? Many of the times we get a question, what is me? Okay, me is a keyword, and it is a self-reference. It is a self-reference of the object who has object who has invoked the method. Okay, very important. Me can be only used inside an instance method. It can only be used inside an instance method. Very important statement. It can be only used inside an instance method because what the first statement says is it is a self-reference of the object who has invoked the method. Okay, so first of all, we only require objects to invoke methods which are instance methods. Okay, static methods, to invoke static methods, we do not require an object. Okay, so that is why the me operator can only be used, or the me keyword can only be used inside instance methods, because only instance method require objects for invoking. Okay, static methods do not require objects to invoke. Okay, very important point. So either you can use me arrow name, or if it's fine, you can directly use name also. So just to introduce the concept of me, I have written it in this manner. Just what I need to do is I need to print out the value of name that I'm passing. Very simple and trivial program.
Hello, Akshay.
Yes.
Can you please reshare your screen because Akansha is unable to see the screen.
Okay. Okay. I'll momentarily stop sharing and I'll reshare this. Okay. Is it fine now? Akanksha, are you able to see the screen?
No, I cannot see your screen.
Ma'am, ma'am, can you please rejoin the call?
I'm not able to see the screen.
I'll stop sharing and I'll reshare. Yeah. Are you now able to see the screen? Kindly confirm on the chat box or something if you are able to see the screen.
Yes, Akshay, I guess screen is visible.
Okay. Thank you.
Yeah, it's visible now. Thank you.
Thank you. Yeah. Yeah, I was explaining the me keyword. So me is the self-reference of the object who has invoked the method, and it can only be used inside the instance method. That is what I was explaining. And we have created a new method, get name, to just get the name attribute printed in the output. The value of name. So since get name can be invoked. Remember, get name can be invoked because it's in the public section. So one more important point about the get name method. Such methods which have a returning parameter are called as functional methods. A particular method which have returning parameters, returning parameter can only be one. Okay, and that too it should be returned by value. Remember, we can have n number of exporting parameters. Okay, so returning parameters, I'll just write a note here. There can only be one returning parameter. Okay, and it should be by value. Don't write returning parameter by value, it's going to give you a syntax error. So no worries, you cannot proceed with coding unless and until you uh, declare it to be returning by value. Okay, we can have n number of importing parameters, we can have n number of exporting parameters, we can have n number of changing parameters, but there can only be one returning parameter, and it should always be a value. Whenever a method has a returning parameter, such method is called as a functional method. Such method is called as a functional method. The functional methods can be directly used in place of expressions. Okay. In this case, what I have done is get name is returning the name, and I am directly printing the name. No intermediate variable has been used to print out the name. So that is the use of functional methods. You can directly use in the if statement. If the value returned by the functional method is equal to some other value, then you can proceed. Okay. So that type of usage can be done with a functional method. Yeah, we'll just try to print out the values. Let's see what is happening. I guess there is no need for breakpoint here now. Yeah, simple as that. So always remember that whenever there is a private attribute there, and if you want to read out the private attribute, there must be a method via which the private attribute is exposed. Okay, this is the principle of abstraction. Yeah. Now that is all about the instance constructor. Okay, the instance constructor. What all things can it have? The instance constructor can have importing parameter. Just now we saw. Can have exception parameter. It cannot have returning or exporting or changing parameters. A very important point. An instance constructor can have importing parameters, exception parameters. It cannot have exporting, changing, or returning parameters. Please remember this. It's a very important point we are discussing. So that is how the instance constructor is there, and it is first of all instantiated every time when you create a object of the class. Why these concepts are important is at a later point of time, whenever you are dealing with frameworks and you are getting a certain dump from standard classes, you must be able to trigger the flow or trace the flow of how methods are getting called. Okay, so if it is an instance method that is getting called and you are getting a dump because there was no instantiation of the object, and you need to figure it out where the object is getting instantiated from. Okay, so these sort of things are very helpful. If you know these concepts, uh, then it is very simple to like track what is happening inside a particular class and from where the object is getting instantiated, so on and so forth. If you are not aware of these uh, concepts of object-oriented programming, it becomes rather difficult to exactly judge from where the object is getting instantiated and why the dump is coming, what are the required parameters that are to be sent to the constructor, etc., and what is going wrong and why the object is not getting instantiated. These kind of things, if you want to understand, you need the understanding of these concepts. Okay. So further moving to the next type of constructor, the next type of constructor is the static constructor. Okay. As the name suggests, it's a static. Static constructor is nothing but a static method of the class. Static method. Now, whenever you want to declare static methods or static attributes, what we do is the syntax that we use is class hyphen methods. Okay, and the name of the static constructor is class underscore constructor. The name of the static constructor is class underscore constructor. The name of the instance constructor is constructor itself. Okay. Now the class constructor cannot have any importing, exporting, changing, or returning parameters. It will not take anything as input. Okay. It will not take anything as input. It is merely a method, and it cannot have any parameters. Exception parameters भी नहीं होगा इसके लिए. Okay. A very important point. And again, coming to the implementation section, I will simply write a particular write statement inside the class constructor. Later on, we are going to use this class constructor to understand the singleton pattern, or we can also utilize this class constructor concept while implementing the factory method. Okay. Method, class constructor, and method. Simple write statement I'm going to write. Okay. Just a notification that the class constructor was triggered. Just compile the program. So when we try to execute the program, let's see what happens. Check what is the class constructor was written. Class methods, class constructor. See what happens. The class constructor is invoked only when only for the first time. I guess the spelling that I have written is wrong. That's why the issue is there. That's the name of the constructor. Yeah. Let's check. See what has been printed is class constructor was triggered, and then the statement value of name is whatever the earlier write statement was there. I'll just use a line feed character here. What we need to understand here is that before the object is getting instantiated, what is called is class constructor. Class constructor is getting called. Okay. So if you want to trace the execution, you can just put a debugger here and execute. Okay. So we have placed a debugger at the create object statement where the object is getting instantiated. So this should place a call to the constructor. Okay, that to the instance constructor. The create object statement places a call to the constructor method, instance constructor method. Okay. So once we do F5 on this, where the control has gone, earlier it was going to the constructor method, instance constructor. Now it has gone to the class constructor method. Okay. So whenever we try to create an object, the control goes to the class constructor first and then the instance constructor.
आता त्यांनी किती जरी प्रयत्न केला झाल्याशिवाय राहत.
Please go on mute. If you're speaking to anybody else, please go on mute. So what I was trying to explain is that whenever we try to create an object, the first control goes to the class constructor if it is available in the class. If it is available, earlier it was not available in the class. We had not declared the class constructor, and the control directly went to the instance constructor. Okay, if the instance constructor is also not available, it is actually implicitly available in the class. If you have not written any logic, then you won't see any control transfer between the constructor implementation. Okay. Please go on mute. Those who are not on mute, please go on mute. Yeah. So yeah. Whenever the constructor is available, you will see the control getting transferred to the instance constructor. So what I was trying to explain, this happens when we cause a distraction. I lose my focus. So please be on mute. If you're having any questions, you can definitely ask it at a later point in time. Create object. Whenever you try to create an object, if the class constructor is available, the control will first go to the class constructor. If it is not available, the control will directly go to the instance constructor. Okay. And then execute. Yeah, that is the reason why the first statement is getting printed. Class constructor was triggered. Let's have some more experimentation with this. What I will do is I will create one more object of the class. Two is equal to new. What we are passing is IV name. Giving me a syntax error. Let's check what the syntax error is, and later on we can write some. We can do amends. Let's check what the syntax error is. Exporting is unknown. Okay. Can we remove this? Let's check. Yeah. So that is the proper way of calling or instantiating the object using the new syntax. Okay. So whenever the same statement I'm going to use here. So this time around, value of name for the second object I'm trying to print. So here we are creating the first object of the class. We are printing what is the value of the private attribute. Line number 52 creates a new object and a new reference variable is created on the fly. Okay, we are using that reference variable to print out the private attribute. Now let's execute this program. Just activate this. Execute. Static. Okay, for now, I will just execute it directly. See what has happened. The output, you can see class constructor was triggered. This is coming. The first statement is coming from the class constructor, that is the static constructor. Then the write statement is getting printed. Okay. Then we have instantiated after the write statement, first write statement, we have instantiated the second object for the class. That time the class constructor was not triggered. Okay. And then the write statement. So if you want to debug it, just debug it for better understanding. So the first object is getting instantiated, the control goes to the class constructor. You can see it. Okay, class constructor was triggered. write statement gets executed, the output is generated, value of name is whatever the name we are passing here. Okay. Then this should give a call to the instance constructor. Okay, do an F5 on the statement, line number 52. The control directly goes to the constructor this time around. This is the instance constructor. Okay, this time around the control did not go to the class constructor, it went to the instance constructor directly. And then as you know, the second line is getting printed. So what the conclusion here is that the class constructor is only triggered once. When it is triggered? Whenever the class is accessed for the first time. Okay, so what we can write in, under static constructor is it is invoked only once. When it is invoked? When the class is accessed for the first time. I'm not saying that when first object of the class is created. What I am saying is when the class is accessed for the first time, then the static constructor gets triggered. That is the only time when the static constructor gets triggered. Okay, if you want to be more technically specific, the static constructor is triggered only when the class is accessed for the first time in the internal session, in the current internal session. Okay. There are two types of sessions when an ABAP program executes. One is the internal session and second one is the external session. So I'm not going to dwell into details of internal and external sessions. Okay, so more technically specific statement is this: it is invoked only once when the class is accessed for the first time in the current internal session. Okay. Now let's try to get hold of class is accessed for the first time. Okay. Let's try and get a hold of the statement class is accessed for the first time. So to access a class for the first time is to simply try to write a statement which is going to access either the attribute of a class, can be an attribute or it can be a method. So constructor is also one of the methods. So since this is not that much clear because यहाँ पे हम लोग object create कर रहे हैं तब वो invoke हो रहा है. So what we can do is we can have a class data as well. Class data is nothing but your static attributes, public static attribute we are trying to create here. Let us say stat pttr type integer. So since this is a static attribute, just write a comment here, static attribute. Coming here, I'll try to access the static attribute here. Okay, for accessing the static attribute, we do not require an object of the class. The name of the class is sufficient for us. So just use the name of the class equal to greater than operator, control space. It gives a pop-up of static attribute. Just set its value to 10. Okay, that attribute. Since this is a class data, we are declaring static attribute of type integer, hence value of 10 is possible to set here. Okay. Activate the code. Place the breakpoint here and execute. Yeah, let's press an F5 on this 47th line. Directly, let's see. The class constructor was triggered. That is what the message got printed. Let's debug it in more detail. Let's see whether for create object the static constructor is getting triggered or not. F6. See, now the control has gone directly to the constructor method. Earlier, whenever the create object statement was getting executed, the control first went to the class constructor, then the control went to the constructor. But this time around, whenever the create object statement is getting executed, the control is directly going to the constructor method and not the class constructor. That is because we accessed the class for the first time at line number 47 itself. That time the class constructor got triggered. Okay, and that's why the in the output class constructor was trigger statement is coming. Okay, so that is what we mean by the class is accessed for the first time. So remember, the class constructor or static constructor cannot have any type of parameters, and the first statement is of paramount importance. That instead of numbering it, I can write it as star as well, so that you won't get confused later on. Very important, it is invoked only once and cannot have any type of parameters. So any doubts in this so far? Anybody? Any questions regarding constructors? Yeah, if not, I'm going to proceed forward with the private instantiation of the class. Okay. So hope this is understood by everybody, since there are no questions. Yeah. So we are going to make some small modifications to the existing class, or maybe we can create a new class altogether. So what I'll do is I'll just comment out this code. So the code remains as it is. We create in the same program. Let's keep the program as it is. No need to tamper with the program. We'll create a new program. Hope the constructor thing is clear. That demo. Private instantiation. That is what the name I'll give. So now we are going to explore the public, private, and protected instantiation of the class. I'm just going to explain the private instantiation of the class because it is the most complex scenario that you might occur or encounter. And this has been encountered many times. Surely you guys have displayed the ALV using SALV table class. So that is the scenario that demonstrates the private instantiation of the class. Okay. So demo private instance. Program. Save it as a local object only. Class LCL. Let us say demo only here. Definition. What addition I am going to use is create private. Create private, protected, public. Public is not required to be written. You have to write create protected or create private. So I am going to write create private. And class. So create private in the sense what is happening is issue here. You want me to repeat the use of me. Okay. Girish, I will do that in just 10 to 15 minutes after we finish this concept. Then we can have a Q&A session on today's lecture. Okay. That time we can address your question. We can club your questions all together and we can have those at the end of the session. The definition part has an addition create private. We don't want the definition now. We want the implementation part. So that is it. So what is the implication of create private? Create private, if you write create private addition to the class definition, it implies that the constructor method, particularly the instance constructor in this case, is in the private section of the class. Okay, the implication is that if you write create private, public, or protected, it implies that the visibility of the constructor is either private, public, or protected. Okay, it implies that the constructor, whenever I'm going to use the constructor term, I'm going to specify which constructor I'm talking about. Instance constructor. Instance constructor is in the private section. So if the instance constructor is in the private section, then what happens is that you cannot create an object of the class because a private method cannot be instantiated outside the class. That is what the effective meaning of create private is. Okay. So since we have declared the class definition as create private, we will have what I'll do is I'll majority of the part I'll just copy from the previous program, so it won't take too much time while creating. This program, the simple trivial examples I'm taking just to clarify the concepts that are there in OOPS programming. The more complex scenarios in OOPS will be there in WebDime Pro and OData. Okay, so that time I hope you guys will be able to handle those very easily if you have clear understanding of the concepts that I'm teaching right now. So a private section will have a constructor. What all things are there? Let me check. Yeah, in the private section we have an attribute as well. Just copy it. Instance attribute, instance constructor. We got this. Yeah, the implementation needs to be copied as well for the constructor. Let's do that. Pretty print the code. Okay, then start of selection. Copy paste, majority of the code is copy paste, just a new concept we need to explore. And then same statement we are going to use, create the object. So type LCL, yeah, obviously, since we have changed our code, forgot to change this. Okay, we'll do a syntax check. Yeah, an instance of the class LCL demo cannot be created outside the class. That is what the issue is with create private, because the constructor is in the private section. As you know, in the previous example, we saw that create object places a call to the instance constructor. The instance constructor is not at all reachable here because it is in the private section. Simple as that. Now, what can be done with such a class? Okay, such a class does exist. If you look at standard classes, also are there. CLS LV table is an example for that. LV table. So I'm sure that many of you have already used this class many a times in your projects. Okay, go to the properties tab. What is written is instance generation is private. Okay, instance generation is private. Instance generation is private means directly the meaning is this only, that they have written it create private. I guess it is possible to look at the class code also. Class documentation, somewhere it is possible, yeah. It's possible to look at the source code of the class. From here, I guess we can go we look at it later. So create private is nothing but yeah, you cannot instantiate the class. So what can we do now? What have they done? What do you do when you want to create an object of CLSLV table? We have a method called factory. Okay, we have a method called factory. So this factory method is a static method. Okay? This factory method is a static method and it is public. What it is doing is get new instance of for ALV table object. Okay? What they are doing, what it is returning, it is returning an object of type CLSALV table. Okay, same thing we have to do. Same concept we have to implement here as well. Okay, since the class cannot be instantiated, we need to have a static method with us. Okay, we need to have a static method with us. The static method should be public, otherwise again it won't be reachable. Method, let us say get instance. I won't call the method as factory method. Method get instance, returning value RO yeah, methods, we have to write methods, not method. Okay, while in the definition part we have to write methods, in the implementation part we have to write method. That is one more important thing you need to remember. Okay, type reference to yeah, what we want to return is the instance of this particular class. This is one type of design pattern that we are trying to learn. Okay, this is how frameworks are designed and these patterns are used in designing frameworks. Okay. And framework is a very important part in WebDesign Pro and OData. So if you are able to understand these small design patterns, the similar thing is implemented in larger frameworks as well. Okay. So hence I am trying to explain these things in detail. The get instance method. So since we have declared, again what is important is this method cannot be declared as a instance method, simply because we cannot invoke this method unless and until we have an instance of the class. The main problem that is we are facing is that we cannot instantiate the object since the constructor is in the private section. Okay, so the get instance method must always be a static method. So what I have to write is class hyphen methods. Okay, class hyphen methods. Yeah, there will be class hyphen methods. Yes. Now the implementation part of the instance get instance method. Get instance. We will try to finish this. So here we can call the create object statement. Create object arrow demo. Arrow demo. Yeah. Exporting. IV name is equal to IV name. I will declare an importing parameter. Preferred parameter चाहिए. Importing parameter चाहिए. Yeah. Importing IV value type string and then the return. So one more importing parameter I have added for this get instance method, since the constructor is expecting an input parameter for the object to be created. So I've done this. Okay, IV value. Sorry, IV value must be there. Okay. So now this statement I cannot write here. It is clear from the previous syntax error that we got. So what I need to do is just use this class LCL demo, call the get instance method. Because get instance method requires a parameter to be passed. Porting. The name IV value. IV value is the name. Again, I'm going to hard code some value. Exporting IV value, name I'm passing. Okay, what I'm going to get in return is the object of LCL demo class. Okay, so either you can write it in this manner. So returning means it's a functional method. Get instance method is a functional method. So I just now explained what a functional method is. So it's a functional method, so hence I can write like this. Okay, if you don't want to write like this, then also it is fine. No compulsions. What we can do is you can add a receiving parameter. Receiving parameter. What we are receiving, RO demo. This also is fine. Okay, this way what we can do is we can instantiate a class which has private instantiation set. Okay, so we'll get an object. This is the same thing that we do for CLS ALV table. Okay, so what I'm trying to explain is here from this example we want to implement a singleton pattern. The current code that I have written doesn't implement the singleton pattern. What is a singleton pattern is, in a given internal session only one object of the class can be created. Okay, what is a singleton pattern? Have I written it? Yeah, singleton class concept is in a given internal session only one object of the class can be created. Okay, this concept we want to implement. Currently this particular code is not going to implement that concept, just because I can create multiple objects of the class here as well. So for example, if I write data hello obj2 and just call this method as it is, सेकंड पैरामीटर नहीं लिखना है. Okay, I'll just change the create a breakpoint here. So remember what we're trying to implement is, in a given internal session only one object of the class can be created. Let's check whether our code is doing that. Definitely it is not doing. Till to trace the execution flow, let's do this. So if you check LO constant and LO obj2, both have been instantiated, and these are different instances. The first one is having 10 and second one is having 11. Okay, these are both separate instances or separate objects. Okay, there are various ways of identifying whether the two reference variables are pointing to the same object in the memory. First, you can check the values of the instance attributes. If the values of the instance attributes are different for both the reference variables, definitely they are pointing to different objects in the memory. Okay, so definitely, and moreover in the name of the object also you can identify this is 10 and this is 11. That also is sufficient to tell you that this particular code is not implementing a singleton pattern. So here in this case, we have created two objects of the class. Okay, but what our problem statement is, we are to implement a singleton class. Okay, so how can we do that? It can be simply done by maintaining a static attribute. Can be simply done by maintaining a static attribute. Either the attribute can be maintained in the public section or in the private section or in the protected section, doesn't matter. Here I am going to maintain a static attribute class data object demo type reference to and in the get instance method write a simple logic saying that if is not bound then create the object. Okay, remove this code from here, print it. Okay, object demo is not bound, then create this object and finally what is the arrow demo? There is some tax error, I can sense it. Seems to be fine. Yeah. So what logic we have implemented is that if object demo is not bound, object demo, remember it's a class attribute. Okay, it is a reference variable of type same as that of the class. Okay, it's the class's reference variable. What I am checking is object demo is not bound. Okay, यहाँ पे is not initial is also is initial is also is not initial नहीं use करना है, is initial then create the object. Okay, and pass it as the returning parent. If it is bound, then no need to create a new object, pass the same object. So this should implement your singleton pattern for you. Let's check. Compile it, syntax check, activate. There's a breakpoint here. Okay. Execute. Please pay proper attention to how the execution is flowing. It's very important. Understand this. So we are calling the get instance method for the first time. Okay, passing the parameter to an F5. The control goes to get instance. Object demo is initial right now. Okay, object demo is initial. That is, it is not bound. So it's not bound in the sense create the object. Now I'm going to create the object. Do an F6. Okay. The object has got created here. Value has been set. Okay. Pass the returning parameter, pass it into the returning parameter, come back. Okay, the object has been instantiated here. This is the value. So the next time when the get instance method is triggered, let's see what happens. Now object demo is not initial or it is bound, so no new object will be created. Same object is passed back. So if you check yellow const and yellow obj2, both these reference variables are pointing to the same object. The instance attribute is this. Instance attribute is again the value is same. Although I passed a different parameter value here, the object was not created. This parameter value did not override the existing objects parameter. Okay, so effectively, if I go on calling get instance method n number of times, only one object is going to get created for this entire internal session. Okay, and that one object will be referred by multiple reference variables. Okay, that is how you implement the singleton pattern. Okay, very important point. This is effectively used, as you know, in this particular framework, CLSA LV table classes. Okay, it's a big framework. So this particular singleton, I guess singleton is not used here, but private instantiation is used. Singleton is not used here. Okay, but what I have taught just now is singleton. Yeah, so we'll stop here today. Now is the time for the Q&A sessions. Yes, there is some issue with this particular debugger is still on. Yeah. So let's take some questions now. Yeah. The first question was, can you repeat the use of me once again? Yeah. So me, where is our previous program demo constructor? So we'll debug this. We'll debug this and check. Okay. Just pay attention to the definition of me. Have I written what is me? It is a self-reference. Self-reference means it's a reference variable. Self-reference means it's a reference variable. Me is a reference variable. Me is a reference variable which points to the object, who has invoked the method. Okay, invoked means called the method. Okay, static constructor का छोड़ देते हैं. Yeah. So in the instance constructor here we have used this me. Okay, so F5 करते हैं इसको. अभी me का वैल्यू क्या है देखते हैं. कि me, see, me is nothing but a reference variable. Me is a reference variable of type LCL constructor demo. LCL constructor demo is our class. Okay. So me is nothing but a reference variable which is internally used in all the instance methods to point to the current object who has called the what you can say method. When to use it? When to use it is a proper question. Okay, when to use it, that we'll see. Let us say that the constructor method, the importing parameters name is not iv underscore name, it is simply name. Okay, so if I don't use me, what will happen? Name is equal to name. Okay, you are not able to understand which name is this, whether this name is for the importing parameter or which one, since the attribute name, instance attribute name is same as that of the importing parameters name. We are not able to clearly identify what is the what we are trying to do here. Okay, so what we are actually trying to achieve is we need to copy this importing parameters value into the instance attribute. Okay, since the object is no longer available here, I won't be able to tell which object's attribute I'm trying to fill in. Okay, so if I write me arrow, then what it signifies is whichever object has called this constructor method, you pick up the name attribute of that particular object and fill the value with the importing parameter. Okay, so me operator is to be used whenever name of the importing parameter of the instance method is same as that of the name of one of its instance attribute. Okay, if you have name of the importing parameter same as that of the name of the instance attributes, then to clearly differentiate inside the method what you are trying to access, whether it's an instance attribute or a importing parameter, you use the me operator. Okay, me arrow means you are definitely trying to access the instance attribute and not the importing parameter. Okay, hope this is clear. You can try it on your own also later on. If you have further doubts, you can definitely reach out. When you're trying to do the exercises and you're not able to understand, you can send me a screenshot or something. We can work it out and clear your concepts. Yeah, any other questions from this particular class, today's class? If no, then what I would like to highlight to you guys is just let me present this first of all. These are the courses that we are offering right now. Okay, Advanced ABAP. Currently, we are conducting that particular demo lecture. We are teaching it at 5,000 only. ABAP on HANA, we are teaching it at 7,000. Basic ABAP is being taught at 10,000. So currently we are into demo classes. The demo classes will continue till tomorrow. We had demo classes on Saturday previous week. Monday, Tuesday we had not Monday, Tuesday, Wednesday we conducted classes on basic ABAP. Okay, the links for which have been shared across the groups. Here also I am going to share the links. Okay. So this is the last week for the demo classes. Tomorrow's class will be the last demo class on object-oriented ABAP and advanced ABAP. From that point onwards, you need to confirm your admissions. Then only you will be shared a link for the further lectures. Okay. So yeah, topics covered under advanced ABAP are object-oriented ABAP, file handling, WebDyn Pro ABAP, and OData service development. So advanced ABAP has been coupled with ABAP on HANA as well. If you want to extend yourself from advanced ABAP to ABAP on HANA, you can definitely do that. The ABAP on HANA course will commence after this particular advanced ABAP course. Okay. So these are the points that we are teaching in ABAP on HANA, CDS views in detail, AMDP, ADBC API, and ELV IDA. So this will be completely from the point of view of development. Okay, we will be doing the development in Eclipse IDE using ADT tools. The system that we have is already an S4 HANA system, so no issues with the HANA database. So the batch timings have been already discussed. Still, I am going through it once again. As for basic ABAP, the batches will be conducted on Monday, Tuesday, Wednesday, and for advanced ABAP, the batches will be conducted on a weekly schedule basis on Thursday, Friday, and Saturday. The timings would be 7:30 a.m. to 8:45 a.m. Okay. So advanced ABAP would be completed in around about 2 months. If you're extending yourself for ABAP on HANA, the duration would be 3.5 months. That is 1.5 months extra for ABAP on HANA. Okay, so this is the link that we are sharing for joining the sessions demo. This is the link for the demo sessions only. Okay. Yes, I'm not able to copy it in the presentation mode. Just if you want, you can keep a link with yourself. I'll be just pinging in this chat box. You want the singleton to be explained? Okay. Let's just let me complete this. Yeah, that is the link for the free demo classes. This is the link that we are going to use tomorrow as well for tomorrow's advanced ABAP class. Okay. So these are the links to your basic ABAP lectures that we have conducted so far. There is one more link that we'll be sharing shortly. That is the link for the yesterday's class that we have conducted. You can just go through these links in case you want to have a deeper dive. Okay, this is the first lecture that we had conducted on object-oriented ABAP. I guess this was conducted on Sunday, okay, where we discussed the topics of encapsulation and abstraction. Yeah, again, I would like to highlight that please do confirm your admissions at the earliest. Tomorrow is the last day for the demo classes, after which the link will be shared to only those candidates who have confirmed their admission. The contact details are these. You can contact us on this particular number. It's a WhatsApp number. So if you feel like you are busy and you just want to chat on the WhatsApp, that also is fine. We can arrange that also. If you want much more details regarding what all points that we are going to cover and more queries that you have, you can simply drop in a mail to us on this particular mail ID. Okay. Yeah. Priya wants to understand what is Singleton program. Priya, could you please unmute yourself and exactly what is the concept that you did not understand? The main definition of the Singleton uh, class concept is that we will be able to create only one object of the class in a current program execution scenario. Okay. So for implementing that design pattern, Singleton is nothing but a design pattern. Okay. In that design pattern, uh, the basic requirement is that the class would be instantiated only once within a given internal session. Internal session, if it is quite complicated, you can understand it in this way. In a single execution run, a class would be instantiated only once. Okay. For that, to restrict the instantiation of the class, the first thing that you need to do is, this is not the program that we are looking for. This is the program. Yeah. So yeah, to limit the instantiation of the program, what is important is you need to make the constructor of the program as constructor of the class as private. Okay. That has been done here. The first requirement for implementing the singleton pattern is that the constructor should be in the private section. Yes, checked. This has been done. Okay. Then you need to keep track of the fact that whether the class has been instantiated or not earlier. Whenever you are trying to instantiate the class at any point of time during the execution, you need to check whether the class has been instantiated before this particular call to the constructor. So that for doing that, what we do is we maintain a static attribute, which is a reference variable of the class itself. Okay, so we maintain a static attribute which is of the type reference variable to the class itself. So whenever the program requests the object of the class, like in this particular instance, we are calling the get instance method. So what we expect to do here is we need to get the instance of the class, that is object of the class. So the program is requesting the class to give its instance to it. Okay. So the first check that is performed in the get instance method is whether the object demo reference variable is initial or not. If it is not initial, or if it is bound, then the clear conclusion is that the class has been instantiated before this particular call to get instance method as well. So since the requirement is we need to instantiate only the class once, just the same object is passed back. The same object is passed back without giving call to the constructor at all. Okay. So, but what happens when the class is invoked for the first time? The object demo will be initial. Okay, we can debug this. Other than explaining, we can debug. Simple as that. Okay. So get instance method is going to get called for the first time. Do an F5. Okay. The object demo is initial. Object demo is initial. So its initial means the class has not been instantiated even once. Okay, the class has not been instantiated even once. So we can allow the object to get created. That is because this is the definition of singleton pattern. Only one object at the class can be created. Here no object has been created. So one object can be created. So call the constructor. Create object means what? Give a call to the constructor. Constructor is getting called, the object is getting created. Okay, the object has got created now. Pass the created object back to the calling program. Okay. Yeah. So I got this object here. Okay. Now the line number 50, what it is trying to do is it is trying to create one more object of the class. Get instance method means what? The method is responsible for giving you the object of the class. Okay. So do an F5. Now the check is there, that check whether object demo is initial or not. Okay. So since this is a second call to the get instance method, in the first call the object got instantiated. Okay, and we have maintained it with us. Okay, now the check fails. Okay, what it says is we are not going to create a new object for the class. An object already exists, you use this object only. Okay, so this object is getting passed back as it is. So no new object is created. Both these reference variables are pointing to the same object in the memory. This can be verified by using the instance attributes as well. Okay, that's it. I encourage each one of you to try these concepts on your own. Unless and until you do this, the clarity will not be there and it can be understood only via debugging. Even writing the program is not sufficient. Thorough debugging is required for understanding object-oriented ABAP. I hope this clarifies your concepts. Yeah, I guess we have extended our lecture quite a long. That's it for today. I encourage you guys to contact us if you wish to join or if you need any further information. Please do contact us on the mentioned details. The details have been posted in the chat itself. Thank you all. Have a good day. Let's meet up tomorrow.